Good evening, dear students. Hope you are doing good. Today we'll solve paper 4, February March 2025. It's variant 2 because there is only variant 2 in February March. So let's solve the questions. Question number 1. There is a graph, figure 1.1 show a force extension graph. So you know that this is Hooke's law. On the y-axis, this is a force, and on x-axis, you can see that there is extension. There is extension in meters. Question number 1 is calculate the spring constant. 2 marks. So we know that force is equal to kx. Spring constant times extension. If you want to find k, that will be equal to force time extension. So we can see that the line is constant, gradient is constant. So at any point, you can find the gradient at this point, or any point. So you will get the same answer. So what I'm gonna do? I'm gonna do force over extension. It's mean 1000 Newton divided by 0.02. So that will be we will get 50,000. Okay, what is the unit? Unit is Newton over meter. So there is no unit, so you have to write the unit Newton per meter. So students state that a spring has not reached the limit of proportionality when the force 4500 is applied. State how the graph show that this statement is true. So you can see that in the graph, even after 4500, the line is still straight. Out of 4500 here, the line is still constant. Constant or straight, you can write, or you can mention the graph. The gradient is still constant. Spring can be compressed by a force. The spring described by figure 1.1 compressed by a force acting as extension 0.0 minus 0.025. Determine F force. So this is extension and K is 50,000. So F is equal to Kx. K is 50,000 multiplied by extension is minus because spring is compressed. So extension will be in minus. So we'll get the force, because force is a vector quantity. So we have to put minus sign with it, with the unit Newton. Question D, state whether the force is scalar quantity or vector quantity. Explain your answer. So what is the scalar and vector? Scalar vector means for vector you need to explain the direction as well, and force is a vector quantity. If you write just vector, you will get 1 mark. Why it is vector quantity? Because force have both magnitude and direction. Question number 2, trolley A and B are horizontal frictionless bench. Trolley A move to the right with a constant velocity this. Trolley B is stationary. So it's mean trolley A is moving and trolley B is constant. So speed of trolley B is 0. Question A, state the momentum of the trolley B before the collision. You can see that, first of all, what is momentum? Momentum is represented by P, that is mass time velocity. So in this case, trolley have the mass, but velocity is 0. So momentum will be 0. Explain, because momentum is equal to mass time velocity, and in this case, velocity is 0. So that's why momentum will be 0 for the trolley B. After the collision, The two trolleys are joined and travel with a constant velocity. V to the right, the mass of the trolley A is 0.75 kg. Calculate the mass of B. What is it? Law of conservation of momentum. What is law of conservation of momentum or principle of conservation of momentum? Momentum. So total momentum before collision is equal to total momentum after collision. So what is the total momentum before collision? The momentum of trolley A. What is the velocity of trolley A? That was uh, 0.44. U was 0.44 plus momentum of trolley B was before collision 0 is equal to. So the total momentum after collision, because both trolleys after collision move together, their mass will be added up. For example, the mass of trolley A was 0.75 plus the mass of trolley B is unknown. We have to find it, and they are moving with combined velocity that is 0.1. After solving this, you will get the mass that is equal to 1.1 kg. See, one part, the trolley moves onto a rough surface which exert a force on the trolley and bring them in the rest in 2 seconds. So this is the time, and we need to find the force. We know that the impulse is equal to change in momentum. So force is equal to the rate of change of momentum. How did I this calculate this? We know that impulse is equal to force act on any object for a very short time. That is equal to change in momentum. So if we solve this, we will get change in momentum over time. What was the change in momentum? How much momentum is change? Total mass with their combined velocity. What was their combined velocity? 0.1a divided by the time. Time is 2.6 seconds. So by after calculating this, you will get the force 0.13 Newton. Next question, part 2. A different rough surfaces exert a small resistive force on the trolley. State how this affect the time taken to bring the trolley to rest. Explain your answer. So the time taken will increase because the force will decrease. The force and time are inversely proportional to each other. So we can see that first of all, you will write the statement time increases. Why? So if we take momentum is a constant, so force is inversely proportional to the time. So when the force is decreased, the time is increased. So this is a statement. Question 3, figure 3.1 show a main electric heater used to heat a small room. So this is a shiny metal surface, and these are the heating elements, two heating elements. State the region of electromagnetic spectrum which radiate thermal energy. So there are 7 regions. So one of them is infrared. Infrared region, infrared radiation always coming out from the heating elements. Explain why the shiny metal surface behind the heating element increases the thermal energy radiation into the room. So shining surface is a good reflector. Shiny surface is good reflector. It cannot absorb the heat. So that's why the shiny surface is being used in the heaters. There are 2 points. The second point should be why we use the shiny surface. Shiny surface reflect radiations in all directions. The metal outer casing of heater is earth. State why this is an important for the safety feature. One mark, prevent from electric shock because current choose only that path which there is low resistance. So D part, the main voltage is 230 volt. Two identical heating elements are connected in parallel as you saw in the heater. Heating element has a resistance of 89 ohms. Calculate the current in one heating element. So we know that we have the resistance, we have the voltage, and we need to find the current. That is V is equal to IR, famous Ohm's law, and I is equal to V over R. So I is equal to V over R. So by putting the values 230 divided by 89, we will get the value of the current, that is 2.6 amperes. Part 2, show that electric power of heater approximately. So we have to prove the power of the heater is 1200 watt. State an equation. You can use word or symbol. So we know that power is equal to current time voltage. And there are two rods. So we will use the current of two rods, that will be double of 2.6, that is 5.2 times, that is 230 volt. And when we multiply it, we will get nearly equal to 1200. The exact answer is 1196 watt, which is approximately equal to 1200 watt. The heater 95% efficient at converting electrical work done to the thermal energy. Calculate the thermal energy by emitting the heater in D2 in 60 seconds. Give your answer with two significant figures. So we need to calculate the energy, and in D2, this is D2, this is the answer of power. So if we see the energy, we know that in chapter 8 we have studied about it. Power is the change in energy per unit time. By multiplying T with P, so we'll get energy is equal to power times time. Power is 1200 multiplied by 60 seconds. So you will get the answer after multiplying it, 67,000 joules. But we have to write the answer in two significant figures. So we will write 67 kilojoules. So this is the exact answer. Question 4. A train has a maximum speed of 200 kilometers per hour. It accelerates from rest with constant acceleration of 0.7 meters per second square. Define acceleration. 1 mark. So you can just write rate of change of velocity. Or you can mention the equation as well. Show that the maximum speed of the train is approximately 56 meters per second. The speed is given in 200 kilometer per hour. So we have to change it into meters per second. So what we'll do, 200 kilometers per hour. So I will change kilometer into meters. So that will be equal to 200 and 3 zeros of kilometer divided by. There are 3600 seconds in 1 hour. 56 meters per second. Calculate the time taken for the train to reach maximum speed. So what is the equation of acceleration? That is equal to change in velocity over time. By calculating the time, we can write time is equal to change in velocity over acceleration. The change in velocity, we just found it, 56. The acceleration was 0.7. And you will get the time, that is 79 seconds. Part B1, The train has total mass. Calculate the force which causes the acceleration of the train. As we know that the acceleration was constant 0.7. So if the acceleration was constant, it means the force is constant. So we will apply Newton's second law. Force is equal to mass time acceleration. So by multiplying 440,000 440,000 multiply by acceleration, that was 0.7, and you will get the answer in Newton 3.1 times 10 power 5 newtons. Second part, the train travel into headwind. The force of this headwind oppose the motion of the train. State and explain the effect of the force on the motion of the train. So because there is a resistive force in opposite direction, so acceleration decrease. And if the acceleration is decreased, it's mean acceleration is directly depend upon the force. So the actually the force is reducing. Reduce resultant force.